G'day. Today I'm starting working on the replacement nut. You look at this thing and think, oh, it's not too difficult. You've just got to put a thread in there, shape the outside, and everything's wonderful. But half the battle here is actually working out what the thread is. Pitch isn't so bad. The owner of the mill says that it's a 2.5mm pitch, but trying to work out, is it a 29-degree angle or is it a 30-degree angle? What should the depth of cut be? All that sort of stuff gets very difficult, and so there are a few tricks about that I'll show you, and then we'll probably do a little bit on actual machining of the nut, but that's much more straightforward, or at least parts of it are. So in order to confirm the pitch of the nut, I also asked for the lead screw to be provided, which it has been, and so here I've got an optical microscope. It's an Isoma brand, it's a Swiss-made thing. They're very nice. I had to do a few mods with repairs and things like that, but they've got an internal light source to them too, so you can actually get right down into nooks and crannies. In there, using this and my DRO, which is just hidden around the corner here, I can confirm that pitch, and I can also get a rough idea of the depth of thread by the altering of the focus using the Z-axis, which is all good. When checking something like this, what you do need to remember to do is not only do the middle of the screw, but look at the ends, because the ends are more likely to be unworn. Okay, the majority of mill lead screws, they do a lot of work around the middle. They don't do much work towards the edge, and in this case, the end thread even had some overspray from when the mill was painted, which was reassuring from the point of view of, well, yes, it's going to be relatively unworn and all that sort of thing. Measuring in 2 or 3 places, I got enough confirmation there. It was 2.5mm pitch. I then took that to a CAD program and started drawing out what the profile would be like and trying to reconcile the dimensions I took at the bottom of the thread of the thread versus the top, what I knew of the diameter and all that sort of thing, to try and work out, okay, is it 29 or 30 degrees? The angle I came up with was closer to 29 than to 30. It was actually 28 point something, I think, so I'm happy with that. What I'm going to use here, a thing called thread wires. They come in sets, and there's a range of standard sizes, and the idea behind these is like this. The wires sit on the sides of the thread. They're above the OD of the thread. They don't sit on the bottom. What that means, because the threads are assumed to be to the correct geometry, you can measure across the diameter, and that will tell you where those the sides of the thread actually are. I do this with CAD because I find it easier. There are mathematical formulas to work out, and this will change depending on what the angle of the thread is. So a 55-degree thread, a Whitworth thread, is going to be different from a 60-degree one. However, that tells me the actual size of the thread. That, you know, the OD may be undersized or oversized. I can't rely on that. The ID is basic clearance. I can't rely on that. So that is an important thing. So that enabled me to work out what the depth of cut was, what the length of the thread up here should be versus what I could measure it at, all that sort of stuff. I'm now going to turn up a small piece of lead screw thread. Turn up a small piece of lead screw thread that will allow me to do a bit of a test check as well as do other things when I'm cutting the nut. To use these things, they're absolute buggers because you need 3 hands, but that's sometimes the way things work. I've heard people use bits of plasticine, bits of blue tack. You can buy little plastic holders for these things, but basically what you're doing is that. Okay, you're measuring with a micrometer across those threads, across those wires, sorry, and that gives you more data to input. Here we are in the dark corner of the shed. I've got a small surface grinder here, and to grind specific tips, I've made up a device which looks like this. That's basically a bit of heavy angle with a 5-degree trough there, and then I've got a whole bunch of plates where I've got not only the primary angle, but I've also got a 5-degree relief angle there. It's probably not enough really, it probably should be more like 8 degrees, but at the time I was making these 5 sounded reasonable. So to grind the tip, I'm going to be doing this. I have some holders here, and they basically take a small bit of tool steel. I made these up, you can probably buy them. Those holes had to be hand filed, unfortunately. No brooches that small in my shop. But that holds a piece of tool steel, and then I can position that so on the grinder and grind that to the tip, and because of that 5-degree, I'll also have some relief on the tool, and then flips over and does the other side, so that's all good. These are just held there with a couple of clamps. That's all I found it needs, but that will enable me to get a nice straight grind on those without having to worry about shaky hands on the bench grinder. So I'll grind that up, and then it'll be a matter of probably clamping it there just to get that tip dimension just right, and we can go turning from there. So here I have my ground tip. I've just put a flat on the end. I've then given it a hone just to get the edges going. Now, my friend Phil has made up a jig which makes measuring these flat distances easy, and one day, I might get around to making one of those. But in the meantime, what I'm going to do is I've put a bit of aluminium up here. It doesn't particularly matter what it is, but something soft is nice. Put a bit of aluminium. I've just plunged in a little bit, and what I'm going to do is now get a number drill, which is about the size I'm aiming for, and just see how that fits. I'm using the end of that basically as a pin gauge, and that should give me an idea as to whether I need to take a lick or two more off, or I'm okay. As long as I'm under, I don't mind, because I'll be measuring the finished thread with wires and comparing it to the sample thread I have, so it shouldn't matter. Another thing to notice with this tool holder, or tool bit holder, and this is the reason I made this up, was that I've got a bit of tool steel here. I've ground it to the right shape, but it's only short. What I can do is get a boring bar like this, and this is just a cheap boring bar, and I should really get around to shortening that thread, but maybe. I can then put that straight into this boring bar. That'll sit there. I'll have a bit dangling out the side. I may have to trim that off, but I can use the same ground insert for both doing an external and an internal thread, which to me, if you're making up a matching thread, is quite a nice idea. I've set up the change gears on the lathe for 2.5mm pitch. I've got a blank set up. I've done a scratch pass, and you may just be able to pick up that yes, there is a slight pitch there. The reason I'm going to all this trouble is I need to find out with this tool how far I need to get in to get the appropriate depth. Now I'm going to compare the existing thread with this one using wires, and so if you recall the diagram I put up, independent of the OD, independent of the ID, that should give me a replica of that thread. Once I've got that, I can then try that in the nut for size, although the nut's pretty worn, but the feed-in distance then tells me how much I have to feed in when I put the nut up to get the equivalent thread. So here my nut is on, and it actually turns quite nicely. In fact, it's probably looser than I'd like, but I can say, because the wires read the same, it's probably not any worse than the existing thread. There's an anti-backlash thing here. I don't like them terribly much, but that'll take up any slot there. It's probably a bit unrealistic to expect any thread, lead screw thread, to be backlash free. You're always going to have something, because it's just the nature of the beast. You need that clearance for it to be able to move. I did a wonderful shot of the thread wires here and showing how close I was to where I wanted to be and all that sort of thing, and then realised that I didn't have the camera in focus, so I'll have to try this again. This yellow goo that you see everywhere is grease, and it's one way suggested of keeping thread wires where you want them. Sometimes it works and sometimes it doesn't. Okay. So we're around about where we want to be on target. So that says to me that this is pretty much the same as that thread there. I'm actually a little bit over, but that's okay, because I reckon the grease is pushing things out a smidge. One of the nice things about thread wires, possibly the only redeeming feature, is if this said I'm 3 thou over size, I could wind in directly 3 thou and that would fix that. No need to go for cosines and sines and all that sort of stuff to try and work it out. However, that's the way it works. So my thread pitch is correct. The thread wires say that it's the right diameter, and if I carefully take those out and don't lose them. So here I am about to start boring the nut. I've got my tool set up. I've put a bit more relief on the bottom there to account for being on the inside of the thread. I've got some tape with a mark on it so I know where the depth is. So basically I'm going to feed in, and when I get to depth, stop, wind back a bit, clear, and so on. Okay, and from here on it's just basically a bit of repetition. Sometime later, many passes, I've got a nut that'll take the thread. This is actually the lead screw from the mill. I didn't have room, because I've got a wall there and a tailstock, to put it in from that end, but it does actually manage to fit through the headstock, which is very reassuring, because when cutting an internal thread like this, you've got a bar with spring in it, and so knowing that the size is really helpful. My little stub shaft did help when I got that fitting. I thought, right, I'm very close to being able to try this one, but being long and awkward to manoeuvre, not something you want to do all the time. So that was a bit longer than I expected it to be, but probably important to go through the steps so that people know how it's all done. Thank you for those who've inspired me, and I hope this inspires others to think about cutting their own nuts and repairing lead screws and so on.